It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 9 here, where we're going to talk about a factoring strategy called factoring by grouping. So before we get into that, let's review how we factor a trinomial. So I need you to factor me 8x squared minus 10x plus 3. So pause the video and factor that trinomial for me. So hopefully you noticed there was no GCF, so we need to figure out what multiplies to 24 and adds to negative 10. Well, both of these numbers need to be negative. And I got negative 6 and negative 4. So I split my middle term, and I get negative 6x minus 4x plus 3. And then we look at our first two terms and take out our GCF of 2x. So I get 4x minus 3. So over here I need 4x minus 3. Well, that's kind of what I have here, but I have to take out a factor of negative 1. So I get 2x minus 1 and 4x minus 3 as my two factors. So now I want you to factor this expression below by grouping the terms. So notice that I have 4 terms here. Notice that I have 4 terms here. So I'm going to group them in groups of 2. Kind of like we did back up here. I had 4 terms, and I'm going to group them in groups of 2 and take out GCFs. That's all factoring by grouping is. It's taking out a bunch of greatest common factors. So I get x minus 5. And then over here, well, it looks like I can take out a 4, but I'm going to take out a negative 4 to leave me with x minus 5 again. So now I have that new GCF of x minus 5 that I can factor out, and I'm left with x squared minus 4. And hopefully you're recognizing, hey coach, that right there is the difference of perfect squares, which is going to happen a lot. So now we bring down that x minus 5 because no factors get left behind. And that is my factored completely form there. So grouping. We use grouping when we have 4 or more terms. We talked about how to factor binomials, how to factor trinomials. Now we're talking about a strategy that works when you have 4 or more terms. So let's try to factor these if it can be factored. Grouping isn't the end-all be-all method. It doesn't always work, but we're going to try it. So notice I have 4 terms here, so I'm going to group those 2 and group those 2. So now looking at these first 2 terms here, I can factor out an x squared, and I'm left with 4x minus 1. Over here, I better end up with a 4x minus 1 because I need those 2 binomials to be the same. So what do I need to undistribute? What do I need to divide these by? By a positive 4. Notice I just didn't put 4, I put a positive 4. So now we take out that common factor, 4x minus 1, and we're left with x squared plus 4. So now we should always pause and check, can I keep going? And the answer here is no, because hopefully you realize this is a sum. This is a sum, not a difference. We can only factor the difference, x squared minus 4. We can only factor the difference of perfect squares. We can't factor the sum. 4 terms, let's try grouping. Groups of 2, groups of 2. GCF right there, x plus 2. So I better end up with x plus 2 over there. Well, what times x is negative 1x? So I need a negative 1. But notice, it's not looking good because if I distribute that negative 1 in, I get a positive 2. So that's not working. So this cannot be factored by grouping. It probably can't be factored at all. But right now we're going to say this cannot be factored by grouping. I can't group to factor this. So even though there's 4 terms and it looks really tempting to factor this one, we can't actually factor this by grouping. So we quit. All right, we got some y's thrown in there. Well, let's make our groups and see what happens. So I can take out an x squared. Oh no, I took out an x, so just x plus 3y. So I better end up with x plus 3y over here. No way that can be done. No way that can be done because I got the 3. This looks in, that's what's weird about this. It's not in standard form. So let's see if we can do a little rearranging here to get this into standard form. Let's put that x cubed first. Oh, I'm liking this already because it gets my y's together. It gets the 3's in corresponding places. This looks promising. Let's try grouping again. So I'm going to contradict myself later in this video, but sometimes you need to move the terms around. Sometimes you need to move the terms around, even though in 2 minutes from now I'm going to say don't move the terms around, leave them alone. Sometimes you've got to rearrange the polynomial to get it into a grouping, a factorable form. Notice I just didn't write y, I took out a positive y, and I'm left with 3x plus 1 and x squared plus y. Can't factor that anymore, so we're done. All right, moving on. Slide in. This polynomial isn't cubic. A cubic polynomial is an x to the third. It's cubed. This is actually an x to the fourth polynomial. This one is chordic. This is a chordic polynomial. Chordic meaning quarter, 4, chordic. But there's 4 terms, 1, 2, 3, 4. So let's try grouping. From these first 2 terms, it appears that I can take out an x to the third. And of course, the color changed late. And I'm left with x plus 5. I better get x plus 5 over here. Well, it looks like I need a positive 8. Positive 8, not just 8. X plus 5, x to the third plus 8. Really, coach? Really? It's not difference of squares. That looks like perfect cubes to me. So, all right, yep, this is perfect cubes. I've got my linear factor and my quadratic factor, so I got x plus 2. Then there's a little pattern over here. Square the first, multiply them, square the last. Same sign, opposite, always positive. Hopefully you remember perfect cubes from the other day, and that's that. Bring down the x plus 5 and we're good to go. Not bad. When we factor perfect cubes, this trinomial will 99% of the time be not factorable, so I'm not even going to consider it. So the concept of grouping can be used to factor things with more than 4 terms. So we've been used to doing 4 terms, but notice this has 1, 2, 3, 4, 5, 6 terms. And it looks really weird and you want to combine them, but don't. It looks annoying that the way that it's written this way. Don't combine these like terms, because if I had 6 terms, let me space them out evenly, there's a couple ways I can group them. I can group them in groups of 2. Or I can do groups of 3. So you never know which way you're going to use to factor when you first look at this. But it was written in this weird, bizarre, uncombined way for a reason. It was written in this way so we can apply the grouping technique. So again, let's try just to do 2 groups. I can already tell this is weird. I can already tell this is weird because if I take out a p squared, there's no way it's matching up over there. So let's actually try doing 2 groups of 3. Nope, we just tried 2 groups of 3. Let's try 3 groups of 2. So if I take out a p squared there, all right, that looks promising. Because here I'm going to take out, well, I need p squared minus 4. So I've got to lose a factor of p and a positive 5. And then over here I need p squared minus 4. So let's take out a 6. Which leaves me with p squared minus 4 is my GCF that comes outside. And I'm left with what left over? X squared plus 5p plus 6. I'm going to box that in, but then I'm actually going to unbox that in because that's not my final answer. Because looking at this, you should say, hey there, that's difference of squares. And then here, well, what multiplies to 6? This is a quick trinomial because there's no leading coefficient. There's a leading coefficient of 1. What multiplies to 6 and adds to 5? What multiplies to 6 and adds to 5? 3 plus 2 does. And that's my completely factored form. So notice when I have more than 4 terms, it's intentionally written in this bizarre way for you to group. It's written in this bizarre way for you to easily group the terms together. All right, let's see how many terms we've got here. 1, 2, 3, 4, 5, 6. Well, by the fundamental law of classroom examples, if this was 3 groups of 2, this one's probably 2 groups of 3. So let's start by doing that just to see. GCF x to the third out from there. Lost 3, lost 3, lost all of them. So this trinomial better be over here in this set of parentheses. Yep. Well, what times x squared is x squared? What times 5x is 5x? And what times 4 is 4? Well, a positive 1. So now we take out our GCF, which is this massive chunk here. That times what's left over? X to the third plus 1. And now you're saying, you're kidding me, that was just step 1? Yes, that was just the first step, because now I've got to factor this trinomial. Late color change there. X times x, because it's quick. What multiplies to 4 and adds to 5? Well, I think 4 and 1 multiply to 4 and add to 5. And then you can't, I'm terrible. I'm a terrible human being, because we've got perfect cubes again. 1 cubed is 1, x cubed is x cubed. All right, square the first, multiply them, square the last, same, opposite, always positive. That's factored completely. So sometimes when we group, we're going to be grouping monstrosities of polynomials. This one had 6 terms here. This one up here had 6 terms as well. I could give you 8 terms, 9 terms, anything that's divisible into groups, we can use to group these polynomials. So on that note, I'll see you in the next lesson, next video. Whenever I see you again, who knows? Goodbye, folks.